We're now jumping to Unit 7.5. This is graphing square root and cube root functions. We're starting with number 26. It says y equals parentheses x minus 7 to the 1/3. This is a cube root function. And as such, we're going to compare it against y equals a cube root of x minus h plus k. In this way, we can compare it to this form and find a, h, and k and allow those to help us with our graphing. In addition, we'll set up a data table, and this will give us all the information that we need. Notice, looking at our equation, that our a value is equal to 1, our h is equal to 7, and our k is equal to 0. This says that the middle point of our cube root function is going to be at 7, 0. Right about here. I'm going to put that value in the middle of our table. Because I know that the cube root function allows me to be able to take the cube root of 0, which is what happens when you put 7 in here, but I can also take the cube root of -1 and of +1. So I know that I can find values for 6 and 8 if I plug them in for x. 6 minus 7 is -1. Cube root of -1 is -1. Again, let's plug in 8. 8 minus 7 is 1. Cube root of 1 is 1. This gives me 2 more points to place on my graph. Now, 2 other numbers that I can easily take the cube root of are -8 and +8. If I want what's in parentheses here to equal -8, then my x would have to equal -1. -1 minus 7 is -8, and the cube root of -8 is -2. I can do the same thing, trying to make what's in the parentheses equal to 8. In order to get 8 in those parentheses, my x would have to be 15, such that 15 minus 7 is 8, and the cube root of that is 2. This gives me 2 additional points. Notice only one of them will fit on the graph, and that's at -1, -2. The graph is going to go through these 3 points and then continue to the left, slowly going downward and through that other point. We do have another point way out here at 15, and so we'll make our graph go through something that's approximately at 15 too. Now, if we want to discuss domain and range of a cubic function, of a cube root function are always -infinity to +infinity, or all real numbers. From left to right, -infinity to +infinity, and range from lowest to highest. Notice this is going down forever and ever and up forever and ever, even though it's doing it slowly. If we want to discuss the transformations, notice an a of 1 means that it keeps the same size and shape, does not stretch or shrink. An h of 7 means that it has translated or shifted to the right 7 units. And a k value of 0 says that it has not shifted up or down at all. So the only real transformation here is the shifted right 7 units.